Lesson 6 we're looking at is called Represent Polygons on the Coordinate Plane. And basically what we're going to be doing is finding distances and then a lot of cases finding perimeters of these different shapes. So if we look, this is on page 102. Example 1, they want us to find the perimeter of this rectangle. So an archaeologist used a coordinate plane to map a dig site. She marked the corners of the building with flags as shown. How much rope does she need to go around the building? Okay, in this, I've seen stuff with this before. Archaeologists do actually use coordinates and stuff for finding, like marking where they found things at. Alright, so what we can do here is we're just finding the rope that needs to go around this thing, so really finding the perimeter of the rectangle here. So each of these is, if you look at the scale down here, each of these squares is equal to 1 meter across. So we can kind of just look at this and see how many squares we have going across each side. So going across the bottom, for example, that looks like 6 squares, so 6 meters. We know on rectangles the opposite sides are the same length. So if the bottom is 6, the top has to be 6 also. And then if we look at the sides, there are 5 squares going down each of the sides here. So to find the rope has to go all the way around, so that's the perimeter. So we would have to add these together. When you add, if you want to look for numbers that work well together, called compatible numbers sometimes. So like we know 5 plus 5 is 10, and then 6 plus 6 is 12. And this can get kind of confusing if we're not careful with this. But anyway, if we add those together, then would be a total of 22. So 22 meters would be the perimeter. That would be the amount of rope that they would need. So we look at the try it. It says the archaeologist later decides to extend the roped off area so the new perimeter goes from A to B to the food tent to the working tent and then back to A. How much rope does she need now? So again, just looking at our picture here, the difference is that we still go across A to B, but now we're coming all the way down to the food tent, roping this off over to the working tent, and then back up to A. So the distance across has remained the same. The distance across is still going to be 6. It's just that we've increased our distance going the other direction. So if you count the squares, there are actually 8 squares going up and down as we're looking at it. This is kind of like an overhead view of this. But anyway, then we can see what we need to do here. So from A to B was 6. From B to the food tent was 8. And basically we're going to need then we're going to need 2 6s and 2 8s, right? And again, if you want to, since we're adding, if you want to put those whatever order you want. If you want to put your 6s together and your 8s together, if that's easier for you to add. And then you can see that we need a total of, looks like 28 meters of rope if we go this route. Okay, so 28 meters altogether. Okay, again, the book is going over on the side here. They're working with absolute value stuff, and that's okay. Like I said, long term, I think it's probably going to be easier for you guys to remember, just counting squares or thinking about on a number line how far it is from one thing to the other. But anyway, that's what it would look like if you filled all those in. And the absolute value ways basically is that those were in different quadrants, and that's why we're adding their absolute values. Remember, if they were in the same quadrants, we subtracted. Same, subtract the absolute values. Example 2, we have a rancher that maps the coordinates for a holding pen for his cows. How much fencing does the rancher need to enclose the cow's holding pen? What we're going to do generally on these problems, kind of like we did in the last lesson, is just to simplify things a little bit, we're going to be not worrying about the decimals and fractions. I think it's enough for us just to do it with the integers. Since it's already worked out in your book, we'll not change this problem, but just something to consider for the future. So this one then we need to go all the way around. So we're actually going to have to add all these different pieces together. So from L to M, they worked that out, and that was the distance was 11.75. Okay, again, basically if you take 16.25 minus 4.5, that's going to be the distance between those two. If we go from M to N, that was 10, basically from 4 to negative 6, okay, because that'd be 4 units going to 0, and then 0 to negative 6 would be 6 more units, so total of 10. Going across from N to O, they worked it out is 12.75. And again, with that one, you can look at, from negative 4.5 to 0 is 4.5, and then from 0 to 8.25 is 8.25. So if you add 4.5 and 8.25, that's how we get that 12.75. And then the side is going from negative 6 to negative 12. So negative 6 to negative 12 is 6. And then so notice the boxes here, notice they're going by 2s actually, okay? So we got to be careful about that, not just counting boxes. And then actually what we can do at this point, going from Q to P, that's the same as these other two added together. So like 11.75 plus 12.75, that would be one way we could get that is 24.5 or 24.50. And then this other one, L to Q, we could actually get by adding the 10 and the 6 together, would be 16. Again, you can work that out separately. But anyway, same process as what we did in the last lesson. It's just a lot of more pieces to it. Okay, and then once we get that, we're just adding those together, and then that would be 81 yards of fencing. Okay, so we're going to look at the try it then. Rancher needs to replace the fence for the holding pen. How much fencing does he need? Okay, so this one, same as the last one in your book, they're going by 2s here again, so we can't just count squares. Also, we have decimals here, but I'll tell you what, like I mentioned a minute ago, let's go ahead and just eliminate the decimals just to simplify things. I think is enough for us to do it that way. Okay, so if you think about this, for example, if we're going from A to B, notice our Y is the same. Our Y values are both 14. What's different is the X's, which are 4 and 15. So basically the question, if I'm going from 4 to 15, how far have I gone? So, think about on a number line from 4 to 15, or you can think about these are in the same quadrant, so we could subtract. That distance would be 11. We go from B to C. We've got this time the Y values are different, so we could think about if we're going from 8 to 14. And that would be a distance of 6. Again, they're in the same quadrant as each other, so if you wanted to, you just do 14 minus 8 would be 6. So if we look now from C to D, we'll notice that the x values are different, so we're going over from 10 to 15. So that's a difference of 5. And then we can look at D to E. D to E, we're back to the y values different. We're kind of going alternating here. So y values, we're going from 3 to 8. So if we basically subtract again, those are in the same quadrant, so 8 minus 3 would be 5. Notice E to F is the same as DC, so we can go ahead and just say that's going to be 5 automatically. If you want to rework it to make sure you did it correctly, you can. And then F to G, we have different y coordinates. These are in different quadrants this time, so we might want to think about this a little bit differently. We're looking from -2 to 3. Now -2 to 3, if you guys want to just make your own number line and think about -2 to 3, you can, or if you can picture it here, that's fine. I'm just going to do it on the number line here real quick. So -2 to 3, I can think about -2 to 0 is how far?
2.
Good. 2 away. And 0 to 3 is how far away?
2.
Would be 3. Okay. And so then all together, basically, if we just add those, then that would be a distance of 5 units. H to G or G to H, we're back in the same quadrant again. The x values changed here, so we changed the numbers, but so we're going from 4 to 15. And that would be a distance of 11. Again, basically, if you take 15 minus 4. Okay, and then this other part we've got from A to H. A to H, if we do this correctly, that should be the same as these other 3 vertical pieces over here added together. Okay, if that makes sense. This would be the same as all 3 of those added together. Or we can just work it out to double check ourselves. Basically, our y values, we're going from -2 up to 14. So -2 to 14. So -2 to 0 would be a distance of 2. And then 0 to 14 would be a distance of 14. So if we just add those 2 together, would be 16. So we've got all the pieces now. Now it's just a matter of adding all of those numbers together. Okay, so that's quite a bit there. So we'll just add. So we've got 11, 6, 5, 5, 5, 5, 11, and 16. I kind of like this here that I've got all these 5s. So I'm just going to kind of group those together and say 4 5s is going to make 20. I've got a 6 and a 6. I'm going to have a mess here in a minute, but that's okay. 6 and a 6 makes 12. And then my 2 1s, 1 plus 1 makes 2. That's just with my 1 digits here. So my 1 digits, if I add those, it's a little bit easier since I've got different colors to keep track of what I'm doing. That would be 34. Carry the 3. And so then that would be 6. So 64 yards would be our total fencing that would be needed. And that's assuming that the you know, what our value is worth here on the picture. The actual answer, if we didn't change the numbers, the answer using the book's numbers would have been 63.5 yards. So we didn't change it by a whole lot, and you know, probably not too bad a shape. Having a little bit of extra fencing might be not a bad idea. Example 3, they're asking if these two triangles are isosceles. So first of all, we have to recall what isosceles means. Isosceles means that two sides have the same length. So we're looking at triangle ABC and BCD. So ABC and BCD. We're looking at these little triangles on top here, okay? And the question is whether they're isosceles or not. So what we can do is we can measure these straight sides. And so looking at this, from A to C, for example, we're going from, we don't see the number in between here, but that would have to be -5 over 2. There's not a number there, but it would have to be 1. So we're going from -5 to 1. So we can kind of break that down. -5 to 1. If we go from -5 to 0, would be a distance of 5. And then we'll go from 0 to 1. So that's 1 unit. And then we can just add those together and see that that's a total of 6. And then we can look at this from B to C. Now B to C, if you look, I've kind of covered up some numbers here, but we're looking from 2 to 8. So that would be a distance of 6. So it looks like this triangle ABC has two sides that are the same length. Now you might say, well, what about that other side? Could that other side also be the same? The answer is no. You'll get into learning more about this with some of your geometry stuff, but the only way you can have an equilateral triangle, there's 180 degrees total in a triangle, and the only way you can have an equilateral triangle is if all the angles equal 60 degrees. We have a right angle in the corner here, and so we definitely have A to B is a longer distance there, okay? This is kind of like if you're trying to go somewhere, your quickest route is going directly, like if I'm trying to get from A to B, my quickest route is going from A to B, right? Okay, so that's my shortest route rather than going from A to C to B. So in other words, A to C to B, that'd be a total of 12. A to B is going to be less than 12, but it's going to be more than 6 for sure. Okay, so just something to think about there. So ABC is isosceles. The question is, what about this other triangle? Well, the 6 we've already got for B to C. The question is for C to D, what is that? So we're going from 1 to 7. 1 to 7 would be a distance of 6. And so that would be also an isosceles triangle. So there's the work the book did, and again, those would be isosceles. So look at the try it. Joaquin says the quadrilateral ADEF is a square. Is he correct? So this, we have to have some knowledge about squares. So on a square, all the sides are the same length. We can actually use some prior information that we've already done here. We had A to C was 6 and C to D was 6. So that'd be a total of 12. That's a total of 12 going all the way across here. And since FE is going straight across the same way, that's going to be 12 also. Okay, if you want to confirm that, we're going from -5 to 7. So, you know, -5 to 7, we can split that up. So -5 to 0 would be 5 units, and then going from 0 to 7 would be 7 units. And so altogether, 5 plus 7 is 12. That matches with what we had on the top part. So now the only question is if these other two sides match up or not. So F, my Y value for that is at -8. So we're going to go from -8 up to 2, it looks like. So -8 to 2, we might want to split that up again. So think about -8 to 0, which would be 8. And then we're going from 0 to 2, which would be 2. And so 8 plus 2 is 10. And this is 10. The others were 12. So it actually is not a square. It's a rectangle. It's not a square, though, because all the sides are not the same length. There's some problems in your book, the do you know how and things like that, but we're going to go ahead and look at your workbook, page 25, because it has some pictures already drawn. That'll make our process a little bit simpler. So workbook page 25, number 1, they want us to find the perimeter of rectangle ABCD. So perimeter is the distance all the way around. Always check first what they're going by. In this case, they are going by ones, so we can just count by ones, count squares basically. If they're not going by ones, we got to think a little bit differently. But so if we just want to look at this going straight across here from A to B, that would be 3 units across from A to B. D to C looks to be the same, and then the only question is vertically how far we're going here. And these have the squares nicely for us. You can count the squares. That's 6 squares, that's 6 squares. And then for our perimeter then, we're just going to add those together. Even though some of this might be, you might think, well, this is just simple stuff and I can add those in my head. You still want to write down what you're doing in case you add incorrectly. Then we've got work to look at so we can say, oh, you knew what to do, you just added wrong. So this would be a total of 18, and they're not telling us if this is miles or what it is exactly, so we're just going to say 18 units is our distance. Number 5, you got to be careful with this one. They mention in this problem that each unit on the grid represents a ½ yard. So what you can do if you want to, you could count by halves. So AB, half 1, 1.5. BC, half 1, 1.5. CD, half 1, 1.5, 2. DE, half 1, 1.5, 2. EF, half 1, 1.5, 2, 2.5, 3, 3.5. AF, half 1, 1.5, 2, 2.5, 3, 3.5. And then we would add those together would be the perimeter. So half and 1.5 and 1.5 is 3, plus 2 is 5, plus 2 is 7, plus 3.5 is 10.5. Plus 3.5 is 14.5. We'd probably want to work that out somewhere and then go from there. So this gives you an idea of representing polygons on the coordinate plane and calculating their perimeters.